For almost a century, humanity believed we had the universe figured out. We thought we understood how everything began. A violent birth called the Big Bang, then darkness, then the first stars, then galaxies slowly forming over billions of years, step by step, piece by piece. Simple, predictable, ordered. But then the James Webb Space Telescope opened its golden eye to the deepest corners of space, and the universe answered back with something nobody expected. Galaxies that shouldn't exist. Not tiny newborn galaxies still struggling to form, but massive, bright, strangely mature structures appearing shockingly close to the beginning of time itself. Some of them formed so early that, according to our current models, the universe simply should not have had enough time to create them. And that's where things start getting uncomfortable. Because when astronomers looked deeper, the problem only got worse. The earliest chapters of the cosmos, the very foundation of modern cosmology, suddenly began showing cracks. What Webb is seeing doesn't completely destroy the Big Bang theory, but it may be revealing that the story we've been telling about the birth of the universe is incomplete. Today, we're diving into the discoveries that are forcing scientists to rethink cosmic history itself, and the terrifying possibility that the early universe evolved far faster, far stranger, and far more violently than anyone ever imagined. It all started with a few unassuming images from the depths of time. Using early observations from the telescope, astronomers looked for galaxies at very high redshifts. And they found them, a handful of tiny reddish dots. But these weren't just any dots. They were galaxies that, according to our theories, were monsters. In early 2023, a report sent shockwaves through the astronomical community. A team identified a gang of 6 candidate galaxies that seemed to exist just 500 to 700 million years after the Big Bang. Now, according to the standard model, a process called hierarchical clustering means galaxies are built from the ground up. Small structures should form first, and only after billions of years do they grow into giants like our Milky Way. But these 6 galaxies were anything but small. Initial estimates suggested they had stellar masses comparable to the modern Milky Way. People were really interested in what the surprises were that we're getting out of Webb. And of course, the big answer was that the first galaxies grew differently than we expected. Finding something this massive, this early, was considered, by all accounts, impossible. As the astronomer who led the research stated, these galaxies were too big to even exist within current models. Our understanding simply didn't have a way to explain how the universe could build something so enormous so quickly. Having these extremely massive galaxies so early in the universe is posing significant challenges. The gas and dark matter needed to build them shouldn't have had time to form. It called the whole picture into question. To understand how significant these new images are, we have to grasp how we look back in time. Light from distant galaxies takes a lot of time to reach us. It would imply that the more distant a galaxy is, the earlier in time we see it. To measure how far a galaxy is from us, we use something called the cosmological redshift. As the universe expands, light from distant galaxies stretches into infrared wavelengths, which the human eye cannot detect. The higher the redshift, the farther away a galaxy is. The Hubble Space Telescope can see only from ultraviolet to near-infrared light, which is why it rarely found extremely distant galaxies. This made astronomers think that there were very few galaxies beyond a certain point. Now here comes the James Webb Space Telescope, which can see in infrared. And objects at redshifts 11 and above can be detected only by infrared light. So, what next? Well, we launched the telescope and pointed it towards the heavens, and voila! A very different picture of the universe started to emerge. Webb's massive 6.5-meter mirror is a master time traveler, specifically designed to capture this highly redshifted ancient light. By analyzing this light, scientists can take a snapshot of a galaxy as it existed in the universe's infancy. It is this powerful capability that has uncovered these objects, now testing our most fundamental theories. The discovery of these impossible galaxies ignited a scramble for answers. The first findings were based on analyzing the brightness and color of the light, a method called photometry. But this can be ambiguous. Could they be something else? To solve the mystery, scientists needed to perform spectroscopy, the astronomical equivalent of a DNA test. By splitting the light into a spectrum, they can lock in a precise measurement of redshift and distance. As this more definitive data came in, the picture grew more complex. For some of the Gang of Six, the follow-up analysis did revise their masses downward. They weren't quite the monsters they first appeared to be, but they were still far more massive and mature than the standard model predicted. The paradox wasn't solved, it had just become more nuanced. Then, another, even more baffling puzzle emerged. A study in 2024 analyzed galaxies from when the universe was only about 600 million years old, and, based on their starlight, claimed some contained stars that appeared to be older than the universe itself at that time. This would be a paradox of the highest order. However, this is where the self-correcting nature of science shines. Further investigation offered other explanations. One is that these early galaxies had bursty star formation, intense, rapid periods of creation that can make a young galaxy look deceptively old. It's also possible that intense radiation created nebular emissions that were misidentified as light from older stars. The older-than-the-universe paradox now appears to have been a misinterpretation of complex data. Yet, even as some paradoxes were clarified, new record breakers emerged that continue to push boundaries. In May 2025, astronomer Rohan Naidu and his team discovered the earliest and most distant galaxy. The light we're seeing from this galaxy started its journey more than 13 billion years ago, long before Earth even existed. And now, thanks to NASA's James Webb Space Telescope, we're finally seeing it. The galaxy is called MOMZ-14, and right now, it holds the record for the farthest galaxy ever detected. Webb first spotted it using its powerful near-infrared camera, or NIRCam, and then confirmed it with another instrument called NIRSpec. What makes this discovery so incredible is that we're seeing MOMZ-14 as it looked just 280 million years after the Big Bang. That's basically the universe in its infancy. But here's the really surprising part. Astronomers didn't expect galaxies this early in the universe to look like this. MOMZ-14 is brighter, smaller, and packed with more chemical elements than scientists thought possible for such an ancient galaxy. And this isn't just another distant object floating in space. Discoveries like this are rewriting the timeline of cosmic evolution. Finding chemically enriched galaxies this early suggests that stars were forming, living, and dying at a breathtaking pace almost immediately after the universe began. That means the early universe may have evolved far faster than our current models predict. And even though another, even farther galaxy might eventually take its place in the record books, MOMZ-14 is still a massive clue in helping scientists understand how the very first galaxies formed, and how the universe evolved in its earliest chapters. The evidence is becoming impossible to ignore. The early universe was producing large, bright, mature galaxies far earlier than anyone expected. And the deeper Webb looks, the stranger the story becomes. These discoveries have plunged cosmology into what many are calling a healthy crisis. The standard model has been incredibly successful, but Webb's data is straining it to its limits. So, what does this all mean? Does it invalidate the Big Bang? The answer from the vast majority of cosmologists is a firm no. The evidence for the Big Bang is overwhelming. What is being challenged is our understanding of the first billion years that followed. Scientists are now questioning how this is possible. First, our models may have drastically underestimated how efficiently early galaxies could form stars. The early universe may have been a much more productive factory than we imagined. Second, the first stars, known as population 3 stars, the chemical enrichment we see might mean these stars formed even earlier and behave differently than we assumed. Third, the seeds of supermassive black holes may have formed much earlier and grown much faster than expected, contributing to the brightness of these early galaxies. And finally, some researchers are cautiously questioning the fundamental components of the lambda-c-DM model itself. Could a different type of dark matter allow structures to form more rapidly? While these ideas are more speculative, science must follow the evidence. Nobel Prize-winning physicist Roger Penrose, in contrast, presents a fascinating explanation. In his theory, he discusses the existence of another universe before the Big Bang. Although this idea is currently controversial, it introduces new avenues for understanding our origins. This isn't a failure, it's the scientific method in action, forcing us to ask deeper questions about our cosmic origins. From a series of faint red smudges of light, a new picture of our universe is emerging, one that was more chaotic and creative in its youth than we ever dared to imagine. Webb has not broken cosmology, but it has broken it open. We are not looking at objects from another universe, we are looking at the most ancient ancestors of our own. The paradox of these galaxies is a clue, a signpost pointing toward a deeper understanding of the laws that govern everything. We stand on the precipice of a revolution, looking back 13.5 billion years, and for the first time, we are beginning to see the dawn. And it looks nothing like what we predicted. That's all we have for you today. Hope you guys liked today's episode. Let us know in the comments. What do you think is the most mind-blowing discovery from the JWST so far? Thanks for watching.